Welcome to the Math Record. Today we'll be learning about hyperbolas. This video will cover the fourth and final part in Chapter 5 of our Precalculus class. In this video, we'll be learning about the conic properties of hyperbolas. So what is a hyperbola? A hyperbola is a collection of points such that the difference of the distance from two points called the foci are a constant. So in this case, it will be like a line. And the hyperbolas look like this. It's kind of like two parabolas, except they have asymptotes. I'll explain these later, the asymptote later on. So we have, let's say, like we have two foci, like they're right here. And now the distance, let's say a distance of a point here, the distance to point here. And then you have another point like right here, and then you have a right here and right here, right? This distance minus this distance is equal to this distance minus this distance. Basically, that's what they're saying. So that is the general concept of hyperbolas. A hyperbola is made out of a center, two foci, and two vertices. So, sorry, something like this. So right here would be the center. Okay, that's how you spell it. The foci. That's how you spell it. The O. And right here are the vertices. Okay, so vertices. And then there's two more things in there's one more thing which in the extra property, which are the asymptotes. Sorry, it doesn't look that good, but like this. Because as the hyperbolas keep going outwards, it kind of gets like really close to these asymptotes, basically. So it gets really close. So those are two, and there's two asymptotes for every single hyperbola. And these points, the foci, the vertices, and the center, they're all on a line called the transverse axes. Okay, so that's the line they're on. And the line that's perpendicular to the transverse axes through the center, it's called the conjugate axis. Okay? So that's basically the general way to write the hyperbolas. There are two types of hyperbolas, which is shown right here. Hyperbola center HK, which is parallel to the x-axis because it's parallel. Because wherever it's concaving at, if concave right, a concave left, and then center at the x. So concave up, concave down is center at the y, so it's parallel to the y. So the transverse axes would be at the x-axis, and the transverse axes for this one will be at the y-axis. And the foci are right here. The vertices, foci and vertices, you see how the foci are further away from the center than the vertices this time? And the general equation. Instead of ellipses where they are adding each other, now they're subtracting each other. And now it's to get that constant, you now have to add the bottom portion of the equation. So in the ellipses solution, to get the constant, you have to have the larger number minus the larger number minus the smaller number, and then you square root it. Now in this case, you have the larger number plus the smaller number, and you square root that, and then you get the new number. So instead of us subtracting from each other, now you're going to be adding them. And then there's these two asymptotes, which is right here. So this is basically the general solution. If you want to screenshot this, you could. If you want to memorize it this way. Yeah, same in all the other cases with the other videos with the parabolas and ellipses. There are these tables to show you how to do it. Anyways, let's kind of go to the examples. first, let's have 9x squared minus 18x minus 16y squared plus 64y and minus 199 is equal to 0. Okay? How do you tell this is a hyperbola? As I said before in the previous video, there has to be an x squared term, and there has to be a y squared term. And also the signs between have to be different. So this one's positive and that's negative. So, or this is negative, it's positive. Since this is negative and this is positive 9 and negative 16, then it's gonna be a hyperbola. So now we're just gonna do the exact same method of what we did with the ellipses. It's basically take out the 9, so distribute the 9 out, so that's 9. Negative 18 divided by 9 is negative 2x. Distribute out the negative 16, that's negative 16. And then y squared. 64 minus negative 16 is negative 4. And then minus 199 is 0. Okay. So 9x negative 2 divided by 2 is negative 1. And that's the square term because you want to get into this general form. Basically the same process of ellipse, but now there's a negative. So that's a plus x squared minus 2x plus 1. So that's a plus 9. So you got to subtract that 9 out. And then you have a minus 16. Y negative 4 divided by 2 is negative 2 squared. So that's y squared minus 4. Sorry, I forgot the y here. Minus 4y, and then plus 4, and that makes minus 64. So you have to add a 64, and then the minus 199 is equal to 0. Then move all the constants to the other side, so you get 9x x minus 1 squared minus 16 y minus 2 squared. So 199 plus 9 minus 64 is using your calculator. 199 minus 64 plus 9 is 144. 9 divided by 144 is 1 over 16. So x minus 1 squared over 16. And 16 divided by 144 is 1 over 9. So it's x minus 2 squared over 9 equals 1. So you divide by 144 from those to get the denominators. And then this is basically the general form for these equations. So now, same process, draw a picture. As like the previous video, you always draw a picture. So how do you know how this looks, basically? Well, what you do is that basically, draw the graph, is that you look at the term, the positive term. This is gotta be negative. The second term is gotta be negative because it's minus something. So the positive term right here is basically the x. The x. Oh, sorry. Why did I write x twice? This one's a y. Sorry about that. That's a y. So basically, this is a positive x term. So the one that's positive is the x. So it's gotta be concave like to the left and concave to the right because it's gotta be parallel to the x. Basically, that's what it tells me. If this is y minus 1 squared and this is x minus 2 squared, so the y is the one that's positive, then it's gonna be concave up and concave down because it's gonna be parallel to the y-axis. And that's how you tell. It's basically just that simple. If you kind of just look at the graph, basically it tells you that too, because it's concave left and concave right, and the x1 is positive, and now this one's y1 is positive, then it's concave up and concave down. Basically that simple. So basically we have a graph like this, so we need to find the center. We gotta find the foci, and we need to find the vertices. And then we also need to find the slant asymptotes. Okay, so we already got the general equation. So let's find the center. The center is right here. It's at 1, 2. Basically, because 1 minus 1 is 0, and 2 minus 1 is 0. Basically, the x and y terms right there. Now for the foci. The foci are further, right? So you gotta remember, this is the only portion you need to remember. It's the b squared plus the a squared term, and then square root gets the constant. So 16 plus the 9, and you square root it to get that constant. So the constant is that 16 plus 9 is 25. Square root of 25 is 5. So the constant is 5. Okay? So to get from C to this focus, you got to add 5. And you got to get C to this focus, you got to minus 5. So what you're going to do is center. Since it's at the X, you got to add 5 here. So it's 5. 1 plus 5 is 6. So 6, 2. And 1 minus 5 is negative 4, 2. So that's the 2 points for the foci. Now the vertices, basically. Alright, I'm going to rewrite this. I'm trying to conserve room. Minus 4. This is the plus 6 one. This one's 6, 2, and this minus 4, 2. Okay. Now the vertices. The vertices are basically the amount right here. So the vertices for this one would be this term, because you gotta think about it. What's the next largest number up here? Because if this is going by 5, then you got the next one, you gotta have the one that's right here, the x, because you're going to the x. So if you're going to the x, you gotta look at this term, which is the 16. So since this is a b squared and this one's going by b, then you got square root the 16. So square root the 16 is 4. So this one's going 4 here, and this one's going plus 4, and this one's going minus 4. Right? So center minus 4. Center plus 4. 1 plus 4 is 5. And the vertices for this one, is 1 minus 4 is negative 3. And that's a 2. So this picture is not the general best picture, but basically it will do. So that's basically how you find it. And then you need to find the asymptotes, which just follows a general formula. So it's y minus the center minus the y coordinate of the center, which is 2, so minus 2, is equal to you gotta think about it. You gotta have this value over because you're gonna have a slope like this. So what we're gonna have is that we're gonna have a number over this number. Since we already know that this number is 4, right? That means the other number has to be this number. So since this is square root 16 is equal to 4, then this is square root 9. So square root 9 is 3. So if you think about it, since you already used 4 here, because this distance right here is 4, that means you have to go 3 up. So now the asymptote is going to be rise over run. So it's going to be going down by 3 and going up, going to the right by 4. Same case here. If you have an asymptote like right here, then it's going to go up by 3. It's going to go 4 to the right and then up by 3. But then in this case, you gotta get 3 down and then 4 to the right, because you already used 4 here. So what you get is that you get plus or minus 3 with square root 9 over square root 16. So that's 3 over 4. And then you put parentheses, and then you put the x coordinate, which is x minus 1. It's x minus the x coordinate of the center, which is x minus 1. So basically, it's just that simple. These are the two equations. So it's plus and minus. So there's a positive version and then the negative slope. The positive slope and the negative slope. And you kind of just expanded it out and you get the two equations, basically. So that's basically how you get the two equations. Is basically just that simple. Let's go to the next example. So now we have negative 25x squared plus 100x plus 144y squared and minus 288y and then minus 3,556 is equal to 0. So basically it's like this. So what you're going to do is you do the same process, divide by negative 25. Distribute out the negative 25. Sorry about that. Negative 25. You get x squared minus 4x plus distribute out the 144. You got y squared minus 2y minus 3,556 is equal to 0. And now you do the number again, so that's negative 25. So negative 4 divided by 2 is negative 2, so x minus 2 squared. So that gets an x squared term, minus 4x. That's a plus 4. So multiply this is negative 100, so you got to add that 100, so you get the same term. Now you got plus 144. Y, negative 2 divided by 2 is negative 1 squared. And then since this is y squared minus 2y and plus 1, so that's plus 144, so you got minus 144. And you have minus 3,556 is equal to 0. And now you gotta move it all to one side, so you get negative 25 x minus 2 squared plus 144 y minus 1 squared is equal to, so 3,556 plus 144 minus 100 is 3,600. Okay. Yeah, so far you have these steps. Let's move this up so we get a little bit more room. And now divide by that's 3,600. So negative 25 divided by 3,600, and you get 144. So you get negative x minus 2 squared divided by 144, and 144 divided by 3,600, you get 1 over 25. So you get y minus 1 squared all over 25 is equal to 1. Change it so it's in the right form, so it's y minus 1 squared over 25. This is the positive number, and then minus the negative. So you minus x minus 2 squared. So you just rearrange it, so you get the proper form, equal to 1. So that's our general form. I see that it's under the y. The y is the positive one, so it's gonna be, if we draw the diagram, it's gonna be concave up and concave down, because it has to be parallel with the y, because it's the y, parallel with the y. So basically, gotta find the center. Oops. Find the center. Find the vertices, and find the foci and the asymptotes. So the center, center, it's at 2, 1. Okay, because x term the y. Now the focis, it's basically the sum. You gotta find the constant. So 144 plus 25, 144 plus 25, square rooted. That's 169. Square root of 169 is 13. So it's gonna be the focis is gonna be 13 up and 13 down. Okay, so the focis are gonna be basically 2, and then 1 plus 13 is 14. And 1 minus 13 is negative 12. So 2, negative 12. Okay? Now vertices. The vertices are going to be under the larger term. So it's got to be under the... it's going to be under, not the larger term. It's going to be under the value of the y. So we see it under the a, which is the 25. So the 25 square root of the 25 is 5. So the vertice is gonna be at 2 plus 1 plus 5, which is 6. And right here, which is 1 minus 5, which is negative 4. The square root of 25 is 5, if I didn't say that before. If I said in the previous example it's the larger number, it's not the largest number. It's the number under the positive coefficient. The positive variable, so that number. So now I have the focis and the vertices and the centers. Now we need to find basically the asymptotes. So we know this is 5, right? So if we already got 5 here, then square root this, that gets 12. So square root of 144 is 12. So we know this goes up by 5. So the other information we know, since it goes up by 5, the only thing that could go over, so rise is 5. So what is run? The only information we have left is the 12. So just rise over run. So it's just 5 over 12 basically. So following the example, you have y minus 1 is equal to rise over run. So you already know this is 5. So plus or minus, because there's always a plus or minus, 5 over the number, which is 12. And then parentheses, that number, which is x minus 2. So basically is just like that. It's just basically that simple. So that covers both of the equations. I hope it helped out pretty well. So that covers all hyperbolas, or what we want you to know for all this class. So that covers like basically all the parabolas, all ellipses, and hyperbolas for chapter 5. Thanks for watching, and I'll see you at the next math record.